All right, so this is Alligations, aka tic-tac-toe math. So Alligations is a little bit of a harder topic than you guys are definitely used to, but I will say that what's hard about Alligations is that it has a lot of steps. It's not so much that, you'll block the sound. It's not so much that it's hard, it just has a lot of steps with it, and that's what kills people. So basically it's like a grid that's set up with numbers from a problem, and then we'll calculate it from there. But the first thing I want to show you, which you can write down, is where these pieces of information belong. Okay, so once we read the question, we'll be placing the numbers in a specific part of the grid, and then it will calculate to be different numbers, okay? But essentially the reason why Alligations exists are how much of something needs to be mixed with something to create something else. That's basically what the long-term requirement of understanding why we need Alligations in the first place. Whenever you make lemonade or Kool-Aid or iced tea or any of that, it's considered an alligation. You're taking some of this and some of that and mixing it together to create something else, okay? So I want us to go ahead and look at the first problem. So the first problem says how much D5W must be mixed with D20W to make 1,000 mLs of D12W. So your question that you're asking yourself right now is, what is D5W? D5W is basically dextrose 5% water. What that means is like sugar water. You know how we have salt water, which is normal saline? It'll say NS. Well, D5W is dextrose in water, and dextrose is like sugar water. So there are 5 grams of sugar for every 100 mLs of the solution. That's, you don't need to know that, but I'm just letting you know what it means. So this is just sugar water. So the number that you see here in the center, those are percentages. So this D5W, that's 5%. This is 20%, that's 12%. And the percentages are what you're putting on the board. So this grid is where your numbers belong, but of course your grid will be empty, so I'm placing your numbers where they belong. This will be a blank grid. Your hair is hanging over this. So on the grid, we need to find out what is our desired concentration. What is the problem asking us to make? Let's look at the problem. It says how much of this must be mixed with that to make this. Whatever comes after make, prepare, create, put together, whenever you see those words, whatever comes after it is the number that is considered desired. So for this problem, 12 is desired. I mean, you could put DW if you want to, but you don't have to. We're specifically looking at the percentages here. So this is telling us to make 1,000 mLs of 12. So 12 is what goes in the center. The higher concentration is 20, simply because it's the larger number. The lower concentration is 5, simply because it's the smaller number. So 5 is the lower, 20 is the higher, and 12 is what you're making. Okay? So that is why your numbers are being placed where they're being placed. The next step that you're going to do is you're going to subtract diagonally. Okay? So you're going to do 20 from 12, which is 8. 5 from 12 is 7. I understand that 5 minus 12 is negative 7, but in Alligations, there's no such thing as negative numbers. You're just subtracting diagonally. Either way. Subtracting diagonally. So you're subtracting 20 from 12, which is 8, 5 from 12, which is 7. And basically, these become parts. Okay? Now you want to find out how many total parts you have. So your total parts are 15. 7 plus 8 is 15 total parts. It's kind of like, let's say that you have stock in a company. You have 15 total parts that are up for divide. 5% owns 8 out of the 15 total parts. The 20% owns 7 out of the 15 total parts, if you wanted to look at it that way, if you're splitting up stock. After you put the parts where they belong, then you're trying to determine how many mLs is that. Because if I sat here and I told you, okay, Namaki, can you go get me 8 parts? You're going to be like, 8 parts? What is that? Like, we don't talk in parts. We speak in mLs. So the next thing that you would have to do is determine how many mLs do these parts belong to. What I personally like to do is I like to pull the information off the grid just to the side so I can see it. So again, the 20%, which is here, the higher concentration, it says that 7 out of the 15 total parts available belongs to 20%. For the 5%, 8 out of the 15 total parts belongs to the 5%. I told you that this is a whole lot of steps. I was not kidding. So you're coming to the end home stretch. Now that you understand how many parts out of the total parts belong to each percentage, you're going to multiply those numbers by 1,000. When you multiply it by 1,000, the 20%, you're doing 7 divided by 15 times 1,000. Remember, you just put it directly into the calculator. You don't hit enter after 7 divided by 15. You just do 7 divided by 15 times 1,000. When you do that, you should get 466.6. And of course, we're going to round up. We're going to round up to 467. And then for the 5%, we're doing the same thing. 8 divided by 15 times 1,000 is 533.3. So remember, it doesn't round up. It just stays the same. So 533. So that's the final answer. The question is asking us how much D5W must be mixed with D20 to make this. So D5, we need 533 mLs of D5. And for D20, we need 467 mLs of that. When you combine these two, it equals 1,000. When you add it together, it equals exactly 1,000 mLs. And then you will have created D12. Remember, it's like a dilution. You're trying to pour these two together to create a different amount.